Hello everyone. I'll start by introducing our main components today. Here I have a small green capacitor and our primary object, a standard Wi-Fi router. Many of us use these daily for internet, but we're going to give it a completely new job as a TV antenna. I'm carefully examining the router. I'm going to remove all the screws on the back of the router. This allows us to access the internal components and modify the device for its new purpose. Leave a comment and let me know which country you are watching from. It's great that we can connect and chat from all over the world. Now, I'm going to gently unscrew the back panel of the router. Being careful here is key so we don't damage any existing components. Next, I'm taking 2 lengths of red electrical wires. I'll meticulously strip the insulation from one end. This exposes the copper wire, which we'll use to create new electrical pathways inside our modified router. I'm twisting the individual strands of the red wire tightly. This ensures a solid, reliable connection and prevents fraying. Now, I take the capacitor, and I will also carefully separate the insulation from its delicate wires. This will allow us to integrate it seamlessly into our new circuit. Similar to the red wires, I'm twisting the copper strands of the green wires. Then, I'm carefully twisting one red wire and one green wire together, creating a robust connection. See how I connected the wires together? Connecting each wire individually may take more time, but it ensures they are securely connected. This is a critical step for linking the capacitor to our new wiring system, making sure it's properly integrated to boost our signal. This step ensures good electrical contact between the wires, maximizing conductivity for our amplified signal. I'll repeat this for the other red and green wire pair. If you find this video interesting, don't forget to like, subscribe, and turn on the notification bell so you don't miss any interesting ideas coming soon. To make soldering easier and more precise, I've secured the wire connections to a small wooden block using clips. This keeps everything steady, allowing for cleaner and more effective soldering. Now, I'm applying solder to firmly join the twisted wires. This soldering is to prepare the tin for the capacitor integration. A strong solder joint ensures excellent electrical conductivity and mechanical stability, which is vital for any electronic modification. I'm repeating the soldering process for the remaining connection, ensuring every joint is secure and free of cold solder. This careful attention to detail will prevent any signal loss or electrical issues later on, making our antenna reliable. With the external wiring prepared, I'm now soldering these new connections directly onto the router circuit board. I'm connecting the wires to specific points on the board. This ensures a strong electrical connection that won't come loose, which is vital for reliable performance. This step effectively integrates our capacitor into the router's existing electronics to enhance its function. I'm carefully positioning the green capacitor and its connected wires inside the router's casing. To ensure everything stays in place and prevent any accidental short circuits, I'm applying hot glue around the capacitor and the newly soldered wires. This provides both crucial insulation and a secure mount for the components, protecting them from movement. It's important to make sure it fits without obstructing any moving parts or ports, keeping the internal layout neat. Now that the internal modifications are complete and secured, I threaded these 2 red wires through the small hole on the side of the router case. I'm making sure all the wires are tucked in and the casing aligns perfectly. Then, I'm screwing the back panel firmly back into place to seal everything up. We now have a router with 2 red wires extending from it. These are our modified antenna outputs. They will carry the amplified TV signal to our custom plug. I used pliers to strip the insulation off the other end of the 2 red wires. We will use these wires to connect the modified router to power. Here's a standard 2-pin electrical plug. I'm unscrewing it to reveal the internal pins, which I'll then remove from the plastic casing. This allows us to modify the plug for our specific needs. I'm connecting the stripped red wires from the router to these metal pins. I'm carefully winding the wires around the screws on the pins and tightening them securely. Then, I'm reassembling the pins back into the white plug casing. This effectively transforms the router's output into a standard plug interface, ready to connect to our custom socket. For the final connection point, I'm having a standard wall socket. I'm carefully removing its outer cover to expose the internal wiring mechanism. This is where we'll integrate our main signal input for the TV antenna. I've taken a coaxial cable, a common cable for TV signals, and I'm carefully stripping its outer and inner insulation to expose the central conductor and the shielding. I will then connect the center core to one electrical prong of the outlet and the braided sheath to the other terminal of the electrical outlet, ensuring a secure connection. I'm tightening the screws firmly to ensure a strong and stable connection, preventing any signal degradation. On the other end of the cable, I stripped the insulation off the same way as before. I'm attaching a specialized coaxial connector. This setup allows the router to receive the television signal through the electrical outlet and transmit it effectively to your TV. I'm showing you my TV displaying a no signal message, proof that nothing is currently connected. I'm plugging the modified router into the power outlet on the block. This connection powers the router and prepares it to process incoming signals. Amazing! We have a crystal clear TV signal. This homemade antenna, ingeniously created from a router and a few components, is actually pulling in channels. You can see various programs appearing on screen, all without a traditional antenna. I easily use the remote control to press the channel button. The TV comes alive with clear channels. To further demonstrate its effectiveness, I'm disconnecting the coaxial cable, and as you can see, the signal immediately drops, showing no signal again. Reconnecting it instantly brings the channels back. This DIY device proves that with a little creativity and some basic tools, you can achieve amazing things, even transforming a common router into a powerful TV antenna. You can see how perfectly it works, bringing in a strong signal where there was none before. This is the power of a little DIY ingenuity, transforming something old into something incredibly useful again. If you enjoyed this project and found it inspiring, please give this video a big thumbs up, share it with your friends, and leave a comment below telling me what other unexpected tools you'd like to see me create. Don't forget to subscribe for more fantastic DIY ideas. Thank you for watching, and I'll see you in the next one.